So I'm Maria. I'm a lead machine learning engineer at Ahold Delhaize. I'm very critical about my coffee. It has to be a latte in the morning. It has to be exactly 8.5 grams grinded coffee. That should be not older than 2 weeks. And it has to run exactly for 25 seconds. And then it should be micro foam. So it's very hard to beat it. And I almost never like coffee anywhere else.
Hi, my name is Basak. I work as machine learning engineer at Ahold Delhaize. I like my coffee Turkish, actually. I drink Turkish coffee every morning. It is strong enough to wake me up.
Hello and welcome everyone to the MLOps.community podcast. I am your host, Dimitri Os, and today I'm joined by none other than Abby. What's happening, Abby?
Oh, wonderful. We have a lot of announcements, but basically we have an event coming up June 15th.
That is happening June 15th and 16th. We've got the Large Language Models in Production virtual conference. So if anyone wants to learn a little bit more about how to use these large language models, that is going to be 2 days worth of nonstop, like 6 hours of streaming, I think. We've got 3 different tracks. We've got workshops, panel discussions, fireside chats, and of course, talks from some of the greatest in the field. I just confirmed the Microsoft DeepSpeed team is going to be there. We've also got Matt Tay from Databricks giving a keynote. And Abby, you're going to be talking there. You're going to be on a panel, right? Leading the evaluation panel.
Yep. But I am really excited about recording this introduction today where we had a conversation with Maria and Basak.
Can I just say one thing before you jump into who Maria and Basak are? They hands down have the best coffee intro, I think, that we have heard. They are very particular, and I like that. They know what they want when it comes to coffee. So who are Maria and Basak?
So right now, both of them are working at Ahold, which is one of the biggest grocery chains across Europe. And Maria, for one, has really interesting background. She worked as a data analyst and then went on to Rise, and currently is now a manager working in ML engineering. In Basak, she's currently working as a machine learning engineer at Ahold. Her background, again, is as a data scientist, and she worked at banks and stuff. So they have such clarity when it comes to thinking about MLOps frameworks and adoption at organizations.
I was so surprised at how mature they were when it comes to the machine learning lifecycle. It is so cool to see this because they talked about, and I don't want to give away too much, but when they jumped into how they were able to standardize and make sure that everyone at Ahold was on the same page and make sure that there were some kind of standards that people were abiding by, and looking at the maturity levels of each one of these groups in their little silos and what was consistent across all of these groups and what were things that people were asking for. And on top of that, what was so cool is that they were referencing a few times in this podcast how they had been thinking about writing a blog, or that they had this maturity assessment questionnaire that they were giving out to their coworkers. And we asked them in the podcast if they would be open to sharing it with the rest of the world. And it is very exciting to say now that that is in blog form, and it is on the MLOps community blog. So we'll leave a link in the description to that in case anyone wants to check out the maturity assessment levels that they put together and how you can correctly assess where your machine learning efforts are going. And especially if you're in a big company, this is just like gold. I really appreciate them giving this to the rest of us.
My best part about this conversation was especially when we asked Maria on which tool comes out to be expensive versus cheaper. And she said it's not really about the tool you use, it's about how you use it. And I think that was one fantastic, or at least like a very different point of view, and probably the right way to think about MLOps maturity and MLOps tooling in this space.
We'll get into this conversation already, huh?
Let's go.
Today, I really wanted to get into some of the challenges of doing ML in the enterprise, and particularly MLOps. And so Maria and Basak, I'm excited to have you both on here to talk about your experiences. And maybe we can start off, Maria, can you kick us off with just how you ended up having such a colorful history and know a little bit about this topic at hand?
Yeah, that's a long story. I think I was always passionate about automating things. I started 9.5 years ago as a data analyst. Data science wasn't really a thing, so you could not get hired as a data scientist. But I was building some churn models at a telecom company in Netherlands, KPN. And I was writing scripts in R back then, so I didn't know Python, but I knew some R. And we scheduled jobs on a server standing in a room, and it could get locked with a key. So it was really funny. We didn't have any servers, nothing fancy, but I wanted to do things in automated fashion already. Then I moved more into data science, building my first APIs, and there was no one who could put things in production for us, so I started doing it myself, just learning how would you do such a thing, talking to software developers in different departments, and getting our first API live. And we also built something called Model Factory back then. It was pretty cool. It's basically we're doing MLOps already 6 years ago. MLOps wasn't a thing back then.
Model Factory, it sounds like an MLOps tool that I have heard of, but I can't remember where.
If you Google it, you can still find our blog on Model Factory back then. And I think Model Factory is not really about what tools you use, but it's more how to get it working together. So I really love MLOps, and I built a version of Model Factory like 4 times all over again with different tools, and also one here at Ahold Delhaize. So
I want to dive into why and how it evolved on these 4 times, like you iterated on it. But Basak, I also want to hear your story.
Yeah, mine is slightly shorter. I first started working as data scientist, and I realized that numerous notebooks were being treated as data science products, and many actually projects were remaining at MVP stage because of operationalization problems. I made a decision to become a ML engineer because it made more sense to fill the gap between data scientists and DevOps engineers. And that's how I actually started working as a ML engineer. So my previous company, it was a Dutch bank. There I developed models, but also deployed models. And then I realized the standardization is actually key when it comes to big enterprise. There we also try to create common solutions for operationalization parts. And now I'm at Ahold Delhaize. Here we actually managed to standardize many things. I think we'll deep dive into that later in the podcast. I find it very fun to actually get things in production because notebooks make no value unless you productionize them.
It's one of those podcasts that I'm realizing I should have blocked off 2 or 3 hours of our time, because just in these opening words, I see that there are so many things that I want to talk about. Not only what we have that we mentioned, the themes that we're going to talk about, but now thinking about standardization or thinking about building a model registry and the evolution of that and how those two things go together. So maybe, Maria, like I imagine you also think strongly of standardization because I saw you bob in your head. And when you were creating these tools, these internal tools, and you saw the evolution of them, how did standardization play a role, if at all?
Yeah, so basically Model Factory or MLOps framework, it's all about creating the golden path of how to do things. Because data scientists, most of the models, they're just the same. So they are doing the same thing all over again when it comes to bringing that to production. So they have developed a script, they have to run it somewhere, and somewhere is usually just one tool that you have to pick. So for example, now at Ahold Delhaize, we use Databricks a lot, and we run jobs on Databricks. Before at KPN, we had a server called Aster that was a product of Teradata, but KPN bought it and we had to use it because, well, didn't have any other choice back then. We also migrated that to Kubernetes, so we were running jobs on Kubernetes. And Also, we were trying to do the same thing on AWS using SageMaker. So there are many tools you could use to do the job. It's just picking the ones that you have in place already. And in large organizations, you already have a lot. So basically, you need to have a version control, and there is already a tool of choice. So we have GitHub, for example, Ahold Delhaize, and for CI/CD, we use here GitHub Actions. At KPN, we used Jenkins back then. So it's really, there are so many tools, and you just have to see what you have and combine them together in a way that is easy to use for data scientists. So they don't have to think about it. So the way how I see it, that they can use the reusable workflows that are developed by a central team. So for example, our team, and they can just have something up and running in 5 minutes. They don't have to think about service user, service principles, so all of those things. It should be minimal for them to start working, start bringing their models to production. That's how I see it.
What is also important, as Maria mentioned, it needs to be easy. When it comes to a solution design for AI products, data science products, it's not about combining 15 tools together and then have a very large end-to-end solution. It's actually more about you choosing what you need, because you already need certain functionalities. You don't need 3 tools that has the same functionality. So what we focused here when it comes to standard solution is choosing the key elements and combining them and having a very simple end-to-end solution. And we provided that as a golden path.
So what does like a standard task for you look like? The reason I ask this is because, again, depending on the task, you would choose very different models. And depending on the models, the pipelines could sometimes differ.
Yeah, I think it really depends on the industry. If you look at Ahold Delhaize, we have 2 types of pipelines. It's a batch job, so we run some kind of pre-processing, and we train a model maybe once per week or once per day, and we create predictions every day, for example. So that's one type of a task. And then these predictions that are created by the model needs to be delivered to some end system. So that those predictions can be used in sending the emails, for example, or they're picked up by some server in another country so that it's being used for demand forecast in the stores. And the other type of models that we have, those are basically APIs. So when you are on the website of one of our shops, you are at the basket, and then you get suggestions of the products that you may want to buy based on your basket. This is an API that we develop. It's a cross-sell API. And for that, the pipeline will be a bit different, of course, right? You have to train a model, but you also need to put that model behind an API. And right now, we have standardized deployment on Kubernetes, so that deploying the same model to another brand, for example, is a very easy task, the deployment process itself. Of course, you have to still fine-tune the model to make it work because the data is different. But the putting it to production, it's literally a couple of minutes. And now we are simplifying it even further by using Databricks serverless API deployment. I know you had a podcast with people from Databricks recently on this topic. So we really like that solution because the way how Kubernetes is used across different brands of Ahold Delhaize, it's a large retail company, it's different. Some have push type of deployment, so you use kubectl commands, and some have pull type of deployments with Argo CD. So you see already a huge difference in how you would bring that to production. But with Databricks, it's just the same.
Maria mentioned about deploying to other brands. Maybe it's actually good to elaborate on that because Ahold Delhaize differs from maybe other enterprise organizations in the sense that it has 19 brands, and all brands, some has data science teams, some has no team at all, but they all want similar data science products because they all have e-commerce websites, they all have grocery stores. So when it comes to standardization, actually for us, it was even a bigger goal standardize things so that if one brand develops a model, let's also give it to other brand and the other brand can just leverage it.
And what does your workflow look like once you start working on a project? I know you're a little bit further into the journey right now, where you've already built the models and you've already chosen your stack. But when you sort of started out in this entire journey of building the MLOps solutions for Ahold, how did you choose? What were the key tools for you, and what was the tech stack going to look like? Or did somebody else previously choose that for you?
Yeah. So when we started to work at Ahold Delhaize, we did MLOps maturity assessment. There are multiple versions of it you can find on the internet. But we develop our own questions, and we ask these questions to different people within the organization per project. So already based on that assessment and talking to people, we knew what kind of tools were used. And it was very clear that everyone was using Databricks for training models. So and Databricks was already within the company for a number of years. So it did make sense to stay with it. And well, as any solution, it has pros and cons. But we found it works quite well for what we need to do because we use Spark a lot for pre-processing. So that solution made sense. Also, multiple brands were using already GitHub Actions for CI/CD. So, and also it's a policy of Ahold Delhaize to use that for software development, and I think model is kind of software in some sense. So we also keep using that, and GitHub was for version control, and Kubernetes was already used for API deployment. So we kind of looked at what is being utilized at the moment, and just to simplify the adoption of what we built, it makes sense to stay with tools that are already used.
We are also on Azure Cloud, so we also have some Azure native solutions that we use.
And so I want to dig into this like ML test score that you did, because I know there was that famous Google paper that came out back in the day, and Microsoft also has their own version of it. And so what did you do? You just sent links to people with a survey and you had them fill that out? Or did you go and shadow people for a day and watch how they were doing things and what their workflow was? What did that look like? And also, how many teams did you actually have to interrogate?
So indeed, we worked through the papers available out there, and but these papers are more on organization level, not really on product level. So we made it really product level, like, do you use version control for your model? Like, as simple as that. When you deploy a model, can you look back what code was used, from what model artifact was used, what data was used for this particular deployment? So these kind of questions, there are 70 of them, I think.
Oh my God.
Yes, we have like also standards. There is a standard document that we use. So we had 70 questions, and we just had interviews with people. We scheduled calls with them, and we asked those questions. Some also we sent this Excel sheet, and we shared Excel sheet in SharePoint, and they were filling it themselves.
This was, I think, 1.5 years ago when we started interrogating people, and we're going to measure your MLOps maturity. Initially, they were scared, and later they were also not happy to see the results, because obviously among those 70 questions, the max I think they achieved was 60%, and they were not very happy to see that. But I think it was also good reflection of their work, so eventually they liked it as well.
So purely heathenistic. Any chance you would open source those questions to the community?
I think we can do that.
Oh my God, that would be so amazing, because I know how many people have come through and asked for something like that. Like, how do I measure what a best practice is, or how do I look at what I should be doing or I should even be focusing on?
Yeah, we can definitely do that. We also have standards document, and I wrote the best practices of data science methodology. It's like 20 pages document. I guess we could open source that, because there is nothing regarding Ahold Delhaize really in it.
So we'll talk later about that. One thing that I would also like to learn is, when you are sharing, because you mentioned, oh, we have a model and maybe we want to share this model with another team, how do you view data sharing concerns, like data access, model sharing, all of that headache that I'm sure there's a lot of DevOps people that are listening, and they're wondering that they're dying to know, like, what is going on in that case.
Well, we don't share data. We don't share models. The only thing we share is the code. So we have a centralized repository for each type of the project. So I was mentioning cross-sell model. Cross-sell model is deployed for 4 different brands, and there is one central repository with the logics of the model. So, and each repository for brand, it's actually using this package, the central package, and there is a configuration file because the data location is of course different, but also hyperparameters of the model can be different. And a model is trained separately for each brand in separate repository, but because it leverages this central package and central deployment framework, it actually makes it really fast to deploy things.
To add on what Maria said, when we develop models, we also keep in mind that multiple brands might use it. So we develop in a way that it can be configured and parameterized. So that's why the central package is more like a Python package imported in every brand repository and used to train and deploy models.
One of the things I'm fascinated by, because you have this very interesting structure within the organization itself, where you have 17 different brands. How does the code review happen internally inside the organization, and what does the process look like? How many people are involved, which is like how many data engineers are there, how many ML engineers, how many data scientists are there? And how long does it take to not just technically, how long does it take to put the model in production, but how long does the inception to the deployment look like?
Yeah, I think it really depends. So our team is a team that helps the brands to become more professional in the machine learning and data science field. Some brands don't have their own data science capabilities. So we have, for example, supermarkets in Greece, Serbia, and Romania. They don't have data scientists at all. So our team develops models for those brands. And we have 4 data scientists and 2 machine learning engineers. So that's pretty much the whole team working on those solutions. And we also have one external machine learning engineer from another team that also helps us. And we have a platform team. And the platform team can be also different per brand, but the Greece, Serbia, and Romania and Belgium, they share the same platform team. And we have an agreement with them how things are deployed from infrastructure point of view, because that is also important. That's the key actually to bring things to production fast. And there are multiple architectural choices that can be made, how those environments are set up. So in our case, for historical reasons, we are on Azure Cloud, and so resource groups are shared across the projects per brand. So each brand has separate resource group per environment, so production, pre-production, development, test environment. So those have the same service principles that are being used by multiple projects, and we keep secrets as organization secrets that are shared across repositories, but we also have some guardrails in place to make sure that those secrets cannot be misused. And that's something that we have in place as a product that our team provides.
Our team is slightly centralized as well, given that we are not attached to any brand. We are working as more consultants to brands from a global team. So this already gives us the chance to actually develop models for multiple brands already since the beginning. And you ask for code reviewing. Well, our team develops the models. Our data scientist develops the models. There are also some data scientists from different brands. They can also contribute. So it's more like a open project within our organization that people can contribute, and the people contributing to that project already follow certain software engineering best practices.
And I think it's also important to mention that the data is, of course, the important part of the whole thing. And there are data engineers on the platform side that make sure that the data arrives to the prepared layer that is being used for the modeling part later on.
The unsung heroes, those data engineers, making sure it arrives in the way that it needs to arrive and when it needs to arrive, all of that good stuff. So there is something that you all mentioned a few minutes ago that I wanted to dig into also, which is not having this tooling sprawl and really looking at the user experience and recognizing that the user doesn't want to have to choose or go between 15 tools to get that whole end-to-end process done. And so it seems like you decided on a select amount of tools, but one thing that I always think about when I look at the MLOps tooling landscape is how vague it is. There's like one tool that will have one value prop, but it also does these 5 other things. And then you have this other tool that has this other value prop, and it does these 5 other things, and there's a lot of overlap. And so when you are choosing which tool you want to use and how you want to interact, how do you just end up on, okay, this is the absolute minimum that we should have, and these are the majority, or these are the most important pieces that we should have. Like, these tools are going to get us 80% of the way there or 90% of the way there.
Yeah. So I think we are coming back to this MLOps maturity assessment questions, right? So we have these questions and we want to go as high as possible in the percentage of the questions answered as yes. So we want to be as mature as possible. And then we need to define how do we do that with the tools that we already have. You need to understand in the corporate environment, it's not easy to get yet another tool, even though that would cover 100% for you. If that tool existed, I don't believe it does. 0 tools do all the magic for you that you need to do. So getting any tool is a big struggle. So you have to do with whatever you have at the moment in a corporate environment. And so we happen to have Databricks, and actually Databricks helped us to cover quite a lot of the points. Of course, you need to, any tools you can use in the right way and you can use it in the wrong way. Databricks makes it easy to use it wrong. Like, you could create a notebook without any version control and you could schedule it, right? You could, and you can claim, well, model it in production, but it's not really following any standards, right? So it's not about the tools, but it's also how you use the tools, I believe.
One of the questions I had was, you mentioned briefly about guardrails that you have in place. Can you go a little bit more and expand on that? What are the kind of guardrails that you have while productionizing your models?
Yeah, so I think I was mentioning the guardrails regarding the organizational secrets that we have in GitHub repositories. So these secrets are being shared across multiple projects, but we need to make sure that those secrets cannot be just used by any repositories. So we can only add a repository in the scope of organizational secret if it follows certain convention. So if it has a certain naming convention, and not everyone can just add it there. It can be only added by a specific workflow, and only certain people can trigger that workflow. So you are being checked whether you're part of certain team in GitHub. And if you are, then only you can trigger that workflow. So in that sense, it's based on whether you are part of the right team to be able to add your repository to the scope of the secrets. And also, if secrets are getting expired, like all secrets do, we have a certain process in place that is run by our platform team to renew the secrets. It's really quite technical, I guess, and depending on different tools that you use, your guardrails may be different, I believe, but that's using the tools that we have. That's how it would look like.
But that makes a lot of sense because, again, this is one of the problems that I've seen, which is basically secret sharing. And the second is credential sharing, which has some sloppy processes that I've seen across organization where you have to have like defined rules on who can access what. And while it sounds prohibitive early on, when you start implementing things, eventually the value delivery is really high. One of the things I wanted to know from you guys was, what was the way of working before these MLOps processes were implemented?
Yeah, that's you
Like a
don't
nightmare.
want to know. Yeah, that was really bad. I think I'm coming from a company where I was in quite luxury position in the sense that, well, telecom company I worked for, they were already using all the best practices. And what I have seen when I started working here, that there were some external companies building data science solutions, and then they would want to put that in production, and they would literally zip the code and create the wheel files and send it over by email to a DevOps team to deploy it. Yeah, I was in shock. Yeah, well, you can imagine, right? The environment where data scientists, create these wheels and run the code, they're also a bit different than the DevOps engineers' environment. So the errors would occur, and then they would send over those errors messages in the email back, and then you would try to reproduce them. So it can take weeks, right, before the issue is resolved. It's a nightmare, and it took us a year to get all permissions we need to deploy ourselves, like getting this organizational secrets for service principals defined in GitHub. So to agree on that, it took us a year.
Yeah, in a nutshell, the biggest change we made with Maria is to actually break the wall between data scientists and DevOps engineers and get the responsibility of deploying models ourselves, because we can create the models and we can deploy the models within the same team. So the ownership stays in the same team, and the errors won't have to be emailed from one team to another team.
And you also had something to say about the distrust between the DevOps engineers and data scientists. Explain a little bit more about that as well.
Yeah. So I believe data scientists, they typically come from econometrics background, statistic background. You see a lot of them. Well, I'm one of them, I guess. And you see DevOps engineers, they know all the best practices, how to build software. Data scientists don't always know about these practices. So, and when DevOps engineers see data scientists doing something that they wouldn't necessarily do, there is distrust that appears. And you need to build that trust between these different teams that data scientists actually can put things in production themselves, because no one would give just permissions like that, right? As I mentioned, it took us a year. So you need to build that trust that you also can handle that yourself in a production environment.
Do you think there's a difference between MLOps and DevOps? Or what are the key differences according to you guys between both the fields? And how does that change between the two different kinds of models that you're putting on, or between the two different systems you have, where one is the forecasting models and the second is the API models? What are the key differences when you're thinking about MLOps and both the things?
Yeah. So I believe there is quite a big difference between MLOps and DevOps, and one comes with, it's not just the code that you need to run to be able to put things in production. It's also the data part, right? And the data part makes all the difference here, because even if your code didn't change, your data did change and errors may appear. And therefore, getting access to production data in development environment might be very important for data science product. And that's also another struggle that I believe many people have because of all the rules to get read access to production data in environments different than production. So that's also the struggle that we had, for example. And it took some convincing to actually get permissions and everything. Another one is checking for the quality, the monitoring, checking for the quality of your model when it's deployed. Because when whatever software is deployed, there are also, of course, some type of health checks that you need to perform. Here, the quality of your model can deteriorate. The model can get worse. And if you don't have those checks in place, you just wouldn't know because, well, from the software point of view, everything is just fine. So these two differences, I think, are the biggest ones.
The classic question that we tend to ask on the monitoring piece is who gets the call when the models deteriorate at 3 a.m.?
Well, I believe that depends on the model. So if you have a model that is critical for the business, in the sense that if it's not working for some reason, you lose a lot of money. So we had such a use case at the previous company I worked at, that it was bad debt model. People would go and get subscription for the mobile phones on the website, and the model will either accept or reject the person from getting a mobile phone with the subscription. And if the model was not answering, it would cost 10,000 euro per hour. So you can imagine these kind of models are critical, right? You need to have some checks in place, and there should be a team that fixes it as soon as possible. And I was also called in the weekends to fix that model, for example. But we personally right now don't have such use cases where fix would be needed at 3 o'clock in the night. Because if a cross-sell model is not working, well, there are some costs maybe involved, but in the night, who is ordering online groceries anyways?
Yeah.
Probably not so many people.
Drunk people.
So I can imagine drunk people. Well, unfortunately, they don't get delivered instantly, so it doesn't make sense for a drunk person to order in the night anyways. It would be delivered like in 2 days maybe, or on the next day in the best case. So yeah, the cost of things not working are not that high. So in that sense, no one gets cold in the night.
But monitoring is still a key.
Yeah.
We are also working on our monitoring component because it's definitely important to keep track on how your model is performing. In our previous way of working before we arrived, we have seen models predicting ridiculous suggestions and not being even recognized. This cross-sell model, for example, imagine an e-commerce website and you just keep seeing trash bags suggested all the time. And why? And this is not being even realized for a long time. So it is not a very expensive cost when it comes to not functioning data science product, but it is still important to keep monitoring.
Yeah, I think it's also the trust of the customer, right? If the customer sees stupid suggestion, they wouldn't pay attention the next time.
Yeah.
So that's like a future cost, accumulative cost that comes with it.
Yeah, I remember one time we had one of our first meetups ever in the MLOps community back in March 2020, Flavio came on, and he was saying that at one of the companies he was at, they recommended to every single user, no matter what the user was, the same item. And I think it was like women's high heels. And so it ended up costing the company a ton of money because the money that they usually get from these extra buys when you have a recommended item that someone clicks on, they lost all of that because they were recommending it, not just for like a few hours. It was 18 days straight before they realized that anything was wrong. And that ended up being something that they realized, wow, this is actually more important than we had originally thought.
We also had this example where the personalized model gave a very expensive gin as a suggestion to all customers. And we had no clue why it happened. And since it was also before MLOps standards, we were not able to track why. But the we don't have a purpose of getting everybody drunk, that's for sure.
It's classic. And that's why people are ordering things in the middle of the night. Now we know. It's because you suggestion. But there is one thing I wanted to follow up on, and it's, you mentioned before about notebooks and how there is now a process around it. And I think that is one of the most contested and hot topics of the MLOps community. And might just be because I bring it up so much. It's a little too cliche now, but what does the process look like from that exploratory phase in notebooks to actually then productionizing it?
So it really depends what kind of notebooks you use. So since we use Databricks, notebooks and Databricks are not exactly the same as IPython notebooks. Luckily, they are not. So they basically just look like Python files, and there is markdown command that Databricks understands as a notebook. So it makes your life a lot easier. So our data scientists love notebooks, as all data scientists do. And they do start developing in a notebook most of the times. But we encourage them to move all functions and all classes that they write outside of the notebook. And Databricks has a nice feature called Databricks repos that allows to use these classes in such a way. And you can also package it. So we also encourage to create Python packages as soon as possible, because the way how we work with Databricks is in production, we build the wheel and we upload the wheel to DBFS. But to test it in a notebook, it's just very easy with this repo feature. So we also use now VS Code extension for Databricks a lot, I believe. I personally have not used it that much, but I guess Basak has more experience with that. Maybe you can tell a bit more about it.
Yeah, we allow our data scientists start from notebook. We don't have any grudge on notebook. They can start exploring, especially in Databricks where they have direct access to data. But we also what we also tell them is to start writing production-ready code. I think this is also one of the important takeaways from what we learned, is that train your data scientists in a way that they write modular functions, they write production-ready code, they start learning some software best practices. And with that, when it comes to actually going to production, we can easily migrate our code from the notebooks to a GitHub repository. Here also Git repos plays an important role because it allows us to synchronize GitHub repositories to Databricks environment. Now also with another feature recently released from Databricks called VS Code extension, they can also develop things locally, but run in Databricks clusters via VS Code. I think this also allows them to already start writing in an IDE while running on Databricks clusters. So this already encourages them to write more mature code.
Yeah, and we also, of course, emphasize on the importance of unit testing. I think that's a key, and also documenting things properly. One part of our pipelines is also doing checks on code quality. So you basically cannot deploy if your code does not look well. And that's if you use our workflows that we provide. So that's something that we also kind of try to enforce, I guess.
And what does the process internally look like when you tell somebody, you want to write production level code? Do you provide people a template internally of what a good code for a model look like? Or is it through constant feedback on their existing code?
Yeah, so when a data scientist starts with the project, we recommend to use our cookie cutter template. And it's not like using a cookie cutter template, it's a workflow that they can run from the repository that we have of cookie cutter repository. And it will create repository for you with all permissions already. So basically, your repository will be added to the scope of organizational secrets, and it will have code that can run. It will have main.py with hello world in it. And then they can deploy it already, this hello world code, but they can also adjust this code. And then there is CI pipeline to check the quality of the code that will run. So those things we already provide as part of this template. We also have, of course, examples of the existing projects where they can see, and we also have some conference documentation on how to do that. And we try to talk to them a lot. I think that's also important piece.
And having examples is already good guideline for them, but I think there's also a bit of trust between us and them. We rely on them to write neat code and follow the guidelines we show them.
So when you look at the whole process that you have now and what you've been able to accomplish, what are the areas that you feel like still need work or you have blind spots in?
Yeah. So one of the things that we already started working on is the cost management. I think that's a very important thing when you are on a cloud, because costs can go high without you even knowing about it. So
Especially on Databricks.
Yeah, well, Databricks can also get expensive if you choose the wrong type of clusters. Anything can, actually. So we tag things properly because resource groups are shared across multiple projects. These workflows that we have, they tag things. So we tag Databricks jobs, and when Databricks jobs are tagged, they will promote the tag to whatever resources Databricks job creates to be able to run the job. And then you can see in Azure cost management how the costs were associated with different runs. That's something that is now being handled by another team, but we would ideally want to have our own dashboard with all the information about all the runs, with some metadata about the runs, but also with the associated costs. So that's something that we want to still improve on. And I think overall monitoring, there is scattered tooling for monitoring that we used across the organization. So some use a lot Grafana, Prometheus, Azure Data Explorer. Elasticsearch is also part of the stack at some teams. So it's really everything you can find we have. And I think it is important first for the platform team to make the decisions on what the tooling we're gonna have, because standardization is a key also for monitoring. And we want to build an integration layer with this monitoring tool of choice for the platform. But because we are waiting for this decision to be made on what tools we're gonna adopt for the whole platform, it's a bit dirty at the moment. I would like monitoring to be improved, but yeah, for that you need to have a tool of choice first. And that goes beyond the MLOps. So this tooling just for everything, right? Not just for machine learning.
So in addition to the cost management, well, actually, since we started focusing on the cost management, we started seeing how much actually a model training costs, literally in euros. And this also motivated us to calculate how much value we actually bring. Because if we are spending more money than we actually are making money, then what's the purpose of having a data science model? And when it comes to recommendation systems, it's a little difficult to calculate the actual revenue you get, because it's not a direct transaction, but we still found our ways to calculate our KPIs, the value in terms of revenue on our websites. And this already allows us to have a clear image of how much model costs and how much value it brings. Not every model brings as much as value as models like demand forecast, for example, but it's still nice to see and compare.
Yeah, and we did already a lot of cost saving, by the way, because we mentioned they were models developed by the third parties, and the way how they were deployed is just crazy. there was a process in place, an Azure function that would create a Kubernetes cluster, and it will then, it's way too big, bigger than it's needed to run a thing. Then it will run a thing, and then the Kubernetes cluster will be killed. So, and every day a new Kubernetes cluster will be created. But if a job failed, then Kubernetes cluster wouldn't be deleted. So you end up having those Kubernetes clusters without any monitoring, having huge amount of costs. So by doing the MLOps in this standardized way, using the framework that we built, we were able to reduce the cost by 90%, 90. That's huge. And also in general, we have seen a lot of processes where we could improve. Like we've seen processes where interactive clusters are being used for Databricks. So it makes sense to move them all to job clusters because of smaller costs on Databricks side. And also to optimize for the VM sizes and VM types on Azure. So we want to move from V2 types to V4, V5, which have better price performance ratio, but also pick just the right size of the cluster to run a job instead of having a bigger cluster that can accommodate for running multiple types of processes. So, and by that, we also are going to save a lot of money.
I think it's a good moment to repeat what Maria said initially. Any tool can be used bad, or any tool can be used good. Any tool can be very expensive, or any tool can be very cheap if you use it wisely. So Databricks can be very expensive, or you can actually find a way to make it cheaper.
Such good wisdom. That is so cool to hear about. And really, I love that you are taking this approach of, hey, we need to prove our worth and we need to show people that what we're doing is actually making the company money. It's not a cost center, it's a profit center. And that gives you so many more resources to be able to champion new projects and show your worth. I want to know, how many people are coming to you asking to use AI and ChatGPT on new projects?
Oh, well, actually, 0. I've never heard anyone asking us to use ChatGPT yet. However, we have a teammate, the principal data scientist. She loves ChatGPT and she's using it a lot for pretty much everything. But I believe it has not created that hype yet within our organization, at least. I believe within many other organizations it did, though. We also had a MLOps conference recently, and we had one talk on how ChatGPT is being used now at IKEA. So there is some change happening at IKEA because of ChatGPT, but I cannot tell yet about our own company.
I started using Copilot on GitHub. I think that's a really nice tool. But indeed, we haven't heard many ChatGPT rumors in our organization, at least not yet.
So you're still untouched by the entire generative LLM hype?
Well, we are touched, but not not as an organization. I believe not yet.
Fantastic. So I think this is a good time we should wrap up this call or interview. But it was really wonderful talking to both of you. I think I can comfortably say, and I've not said it live yet, this was my favorite interview till date, and start.
Wow.
Well, thank you.
Because you guys were so open about all the things, including what your processes look like, as well as talking about model maturities. These are things that I do find a lot of people talking about. Again, the revenue question is something everyone talks about, which is, hey, as a data science team, we need to make revenues, but nobody really puts that in perspective. Some do, but still, I find that missing, at least from a big picture. Brain doesn't make sense. So I really loved this conversation.
Thank you.
Thank you, girls.
I also really enjoyed it. It was really fun.
I definitely enjoyed it.
This is Skylar. I lead machine learning at Health Rhythms. If you want to stay on top of everything happening in MLOps, subscribe to this podcast now. 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 Now.